Good morning, everyone. Today we're going to be looking at Lesson 96 together. I am going to be covering one of the two concepts that's covered in this lesson. The one that I want to cover with you today is the distributive property with algebraic terms. There's a couple reasons I want to skip over the other concept that is covered in this lesson. It's estimating angle measures, and it's teaching you how to use your protractor against the hands of a clock and trying to understand the degrees of each number on the clock in relation to a 360-degree full circle. But I don't have a protractor here at home, and I wasn't really sure how to work with you with the protractor without being together. So I know that you all know how to use a protractor, and so I'm not going to worry too much about that concept of estimating by understanding how the hands of a clock can show an angles measurement as well. So we're going to focus more on the distributive property today. The distributive property is a concept that you must understand in order to move forward into algebra. We touched on it way back in lesson 41 briefly. You guys were using it to distribute with numbers. Now we're going to be looking at distributive property that's got variables involved in it. And as I said, distributive property is used frequently in algebra to simplify expressions and to solve problems. So it is very important that we do understand this concept. So let's take a little bit of time to go through the lesson. This is not a very long lesson, which will be nice for you and for me. So let's go ahead and fill in the very top of your notes if you have those in front of you. And if you don't, go ahead and pause the video and grab your notes. We're going to fill in that very first line up there about the distributive property. I love the definition that, or the explanation that Saxon gives to it. They use the word spreads. So the distributive property spreads multiplication. Let me make this a little bit bigger so I can write easier. Over terms that are algebraically added. Okay, so let me say that in one sweep. The distributive property spreads multiplication over terms that are algebraically added. Okay, so we're going to go ahead and jump right into the first example. There's 4 different examples given there for us to practice, but before we move there, cast your eyes back up at the top for a moment. You're going to see here an equation that says A times the quantity B plus C equals A times B plus A times C. This is what we did in the past, way back in lesson 41, except instead of using variables, there were numbers there. And what it taught you was that if you take the number that's on the outside of these parentheses and you multiply it with each one of the terms in here, you're going to end up with A times B plus A times C. And that's how the distributive property works. That might not seem like a big to-do to you right now, but when you get into algebra problems where you have a variable, an unknown variable in there, you have to get that variable isolated. Well, we have to use the distributive property in many cases to get the variable in a position where we can actually get it isolated. So let's take a look at letter A. So here's the expression we have is 2 times the quantity x minus 3. So we're going to take, just like we did up top there a moment ago, we're going to take the 2. And I want to see you guys actually using these arrows. I think every algebra teacher teaches the arrow concept. It helps you keep track of what you're multiplying together. So we have 2x because we're multiplying 2 times x. This one is a minus sign. 2 times 3, which is 6. That's the first one. Letter B. Now we have a negative 2 out here times x. And this negative 2 times a positive 3. Remember, this sign is attached to that 3. You don't have to necessarily write that right there. But I just want to kind of point that out to you. So negative 2 times a positive 3 is a negative 6. And that would be the answer on distributing that problem. Letter C. Again, I have a negative 2 times x, and negative 2 times a negative 3 is a positive 6. Okay, so that negative sign is attached to the 3. Here I have a positive x. I'm multiplying it with a positive x, so I get x squared, and x times a negative 3 is negative 3x. So there's the answer to all 4 of those problems. Please make sure you have this in your notes, and please use the arrows to sweep across to show what you're multiplying together. If the signs are a little bit confusing to you, we can do what we talked about last time, where you separate inside here if you need to do that for a little while, so that you can see that the sign inside here is attached to the number itself. So this negative sign right here is attached to the 3. This negative sign was attached to the 3. So when I was multiplying up on letter A, when I was multiplying the 2 times a 3, I was actually multiplying that with a negative 3. And that's why it ends up being a negative 6 down here. Okay, let's look at example 2. Example 2 is an expression that's a little bit longer, but I do see in here, right here, I see where we're going to use our distributive property to get that x outside of the parentheses. So let me make this a little bit bigger here. So we're going to just write down x squared right below here, because we're not going to do anything with those terms just yet. And then we're going to take care of our distributing here. So I'm going to distribute 3 times x, which is 3x, and 3 times the negative 2, which is going to give me a negative 6, or minus 6. Okay, so let's see if we have any terms we can combine. I do see 2 x terms right here. So we now have x squared plus 5x minus 6. And that is the final answer for example 2. That is how you use the distributive property. As algebra gets more complicated and the problems get longer and there's more operations going on in there, the distributive property will help tremendously. So it is one of those concepts that you want to get really sound with how to use it. So today you'll have a little bit of practice in your lesson. I hope you enjoyed this concept, and that's it. I will see you shortly on Zoom. Have a great day.